Hello, Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about our project report, which is digital electronics, and our group member consists of 4 members, which is first Muhammad Alif Najbi bin Zanizan, matrix number AA211650. Next, Muhammad Ahmad Izzuddin bin Cik Ramani, matrix number AA211771. And Muhammad Fakri Arif bin Azhar, AA212190, and me, Muhammad Danish Farhan bin Kamaruddin, AA212960. And today, I would like to present about introduction of our group project. In the context of electronics, flip-flop refers to a particular type of gated latch. In the contrast to a gated latch, a flip-flop does not instantly enable its input when it detects a high signal on the clock input. Instead, the inputs are activated by the transition of the clock input. Thus, when the clock input switches from low to high, the inputs are briefly enabled. When the clock stabilizes at the high setting, the flip output flop state is locked until the next clock pulse. Flip-flops are usually referred to as edges triggered by the edge of the clock signal. Edge triggering is a key feature used in clock-driven computer circuits. The clock input is initially low, the inverter used in clock-driven computer circuits. The clock input is initially low, the inverter makes the NAND gate's first input designated 1 high while making the second input low. The output from the NAND gate at point 2 is high because the inputs aren't both high. The second inverter flips the NAND gate output, resulting in the circuit at point 3 having a final output that is low, much like the clock input. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Izzuddin bin Cik Ramani. My matric number is AA211771. Okay, for our digit project, I will be presenting about task A, which is state diagram. Okay, for the first one, we have 001 will go to the 110, and then 010 will also go to 110, and then from 110 it will go to 101, and then it will go to 000. Okay, 111 will go to 000, and then from 000 it will go to 1, so I'm sorry, it will go to 010. From 010 it will go to 100, and then it will back to 110. Okay, that's all for the state diagram. Next, I will move to the state table. Okay, we have two important things here, which is current state for QA, QB, QC. Okay, for the QA, 0, 0, 0, 0, and 1, 1, 1. Okay, we have 0, 0, 1, 1, 0, 0, and 1, 1. And for the QC, we have 0, 1, 0, 1, 0, 1, 0, 1. Okay, for the next state, we have QA is 0, 1, 1, 1, 1, 0, 1, 0. For QB, 1, 1, 0, 1, 1, 0, 0, 0. For the QC, 0, 0, 0, 0, 0, 0, 1, 0. That's all for the state table, and I will move to the excitation table. For our excitation table, we have current state, next state, flip-flop A, flip-flop B, and flip-flop C. Okay, first we go to flip-flop A. For J, we have 0, 1, 1, 1, S, 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 S. For KA, we have S, 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 0, 1, 0, 1. For flip-flop B, the J, we have 1, 1, S, S, 1, 0, S, S. For K, S, S, 1, 0, S, S, 1, 1. For flip-flop C, for the J, we have 0, S, 0, S, 0, S, 1x. For k, x1, 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 x1. Right, that's all for the excitation table. We move to the K map. For K map, for flip-flop A, J, the simplest equation is QC plus QA. For KA, the simplest equation we got is QA. Next, for the flip-flop B, for the J1, the equation that we get is QB bar plus QA bar. We got QA bar plus QB. For the last flip-flop, which is flip-flop C, for the J we have QB, QC. For the KC, we got 1. Okay. From this expression, the circuit that the get circuit that we get is this, like this. Okay, I think that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakri Arif bin Azahar. My number matrix is AA212190. Today I will present about the simulation of our task A, that is FSM, finite state machine, by using the Tinkercad. In this Tinkercad, I have used many components to make the simulation. Such as I have used the JK flip-flop, that is 7473, AND gate, that is 7408, and OR gate, that is 7432. I also has used the resistor, LED, power supply, and function generator to make this circuit. Then first step that I have done to make this circuit, I has take out the breadboard, and then I have arranged the IC of JK flip-flop and the AND gate and OR gate in the middle of the breadboard. After that, I have made the connection between the IC based on the circuit that we have done, that our group have done. After finish all the connection of the by the IC, I have connected I also have connected the breadboard with the LED and resistor. Then I connected with the power supply and function generator. Then after finish all the connection, I start the simulation. I start the simulation, and our simulation have been done successfully because the LED has been light up. So by using the Tinkercad, we can make the simulation of the circuit become more easier, because in the Tinkercad, we just only to pull up the wire to connect it to make the connection in the circuit. Then there is also many component that have in the Tinkercad that we can find. Okay, that was for me. Let's continue for another presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Najmi bin Zainizat. My metric number is AA211650. I'm from group 26, section 4. Today I want to present my circuit that I create in Logistics. So this is for the input, and this is for the output, clock and clear. Alright. For the line 1, clear will be 1, and all the input will be 1 also. So for the output will be 0, 0, 0, 0. And for the line 2, clear will be 0, and the output will be the same, 0, 0, 0, and 0. For the line 3, clear will be 1 and B will be 0. So the output will be 0, 1, 0, 0, 1 in the output B. For the line 4, B will be 1, clear will be 1, and clock will be 1. So for the output will be 0, 0, 1, 0. C will be 1. Okay. For the line 5, clock will be closed and open again. So the output will be 0, 0, 0, 1. D will be 1. For the line 6, 0, clock will be closed and open again. And the output will be 1, 0, 0, 0. 1 will be at output A. And for the line 7, clock will be 4. That will I close and I open again. And the output will be 0, 1, 0, 0. 1 at output B. And for the line number 8, clock will be 5. Close and open again. And the output will be 0, 0, 1, 0. And at the lines 9, clear will be 0. Clear will be 0 and the clock will be closed. And the output will be 0, 0, 0, 0. Okay, for the line 10, clear will be 1 and at the input B and C will be 0, 0. Right? So the output will be 0, 1, 1, 0. 1 will be output B and output C. So for the line number 11, we will open C and input C and B will be 1 and the clock will be open again. So for the input, the output will be 0, 0, 1, 1. And for the line number 12, the clock will be closed and open again. So the output will be 1, 0, 0, 1. The number 1 at output A and output B. So for the 13, line number 13, the clock will be closed and open again. So for the output will be A8, 1, 1, 0, 0. 1 will be at output A and B. Right. For the line number 40, the clock will be closed again and open again. So the output will be 0, 1, 1, 0. 1 at output B and output C. So for the last line is number 50. The clock will be closed and open again, and the output will be 0, 0, 1, 1. Number 1 at output C and D. So that's all for me. Thank you.